Sklearn, calibrate a multi-label classification with calibrated classifier. I have built a number of Sklearn classifier models to perform multi-label classification, and I would like to calibrate their predict_proba output so that I can obtain confidence scores. I would also like to use metrics such as sklearn.metrics.recall_score to evaluate them. I have 4 labels to predict, and the true labels are multi-hot encoded, for example, 0, 1, 1, 1. As a result, calibrated classifier does not directly accept my data. This would return an error. Thus, I tried to wrap it in a one-stressed classifier. Note that multi-output classifier and classifier chain do not work, even though they possibly suit my problem better. It works, but the predict output of the calibrated classifier is multi-class instead of multi-label because of its implementation. There are 4 classes, 0, 1, 2, 3, but if there is no need to put a label, it still predicts a 0. Upon further inspection by means of calibration curves, it turns out the base estimator wrapped inside the calibrated classifier is not calibrated at all. That is, calibrated_CLF.calibrated_classifiers_0.base_estimator returns the same CLF as before calibration. I would like to observe the performance of my calibrated models doing deterministic, predict, and probabilistic predict_proba predictions. How should I design my model/wrap things in other containers to get both calibrated probabilities for each label and comprehensible label predictions?
In your example, you're using a decision tree classifier which by default support targets of dimension n, m, where m is greater than 1. However, if you want to have as result the marginal probability of each class, then use the one-stressed classifier dot. Notice that calibrated classifier expects target to be 1D, so the trick is to extend it to support multi-label classification with multi-output classifier. Full example. Notice that the result from predict_proba is a list with 4 arrays. Each array is the probability to belong to the class I. For example, inside the first sample of the first array is the probability that first sample belongs to class 1, and so on. Regarding the calibration curves, scikit-learn provides examples to plot probability path for 2-dimension and 3-dimension targets.
If you want to support the channel, please consider subscribing.